Good day, math learners! Welcome to Session 6, Equation of a Parabola. In today's session, we will try to determine the equation of a parabola. Our specific objective for this session is to determine the standard form of the equation of a parabola. Alright, so our business for today is to determine the equation of a parabola. So let this be our y-line of our Cartesian coordinate system. Let this be our y and this our x. And let this be our directrix L. Okay? Let us try to identify our focus. Let this be our focus. This point here is our focus. F, and from F to the origin, that's C. So therefore, the coordinates here is 0, C. And if from the origin to this is equal to the distance from the origin to F, so this is also C. Therefore, at this point, it is negative C. And so, the equation of our directrix is y equal to negative c. Okay? And if that is so, then the origin is a point on our parabola. And if we want to find the rest of the points belonging to the parabola, then it could be the points on this curve. Okay? So that one. All right. And so our concern now is to determine the equation of our parabola. Let this point be point P. Okay, this point. Let this be point P. And point P has coordinates x, y. Okay? And so if we want to find, because this point belongs to the parabola, let's try to extend our directrix first. Okay, we extend our directrix to the right. Okay, so if point P is on the parabola, therefore we can say that the distance of P to F, okay, the distance of P to F would be equal to the distance of P to line L. Okay, this distance here. Therefore, this and this are equal. And let us try to identify this point, to name this point as point on the line, so P sub L. Therefore, the distance of P to P sub L, because this point is on the parabola, is equal to the distance of P to F. And if we write that, that would be P to F, the distance of PF, is equal to the distance of P, point P to P sub L. Okay? And this is based on the definition of a parabola, that the points on the parabola have distances which are equal from the point to the focus and from the point to the directrix. Alright? So, if this is so, we can solve for the distances of both segments using the distance formula. So the distance formula is the sum of the squares of the differences of the x coordinates and the y coordinates of the segments. So it would be better if we determine the coordinates of P of F and P sub L and then try to put it on the formula. So here, let's try to identify it first. So P has coordinates xy. There, this one. Okay. F has coordinates 0c, this. And P sub L has coordinates, what's the coordinate on this point here? This would be x, whatever the x is. Okay? Whatever the x is, so that's x and negative c. because the equation of the directrix is y equal to negative c, then any point here would have an x as its x coordinate and negative c. Okay, so P sub L has coordinates x and negative c. Alright, so when we put that to the formula, we have P, we have x, this one, minus f, the x coordinate of f, which is 0. And we go to the y, this is y minus c. Okay, for P and P sub L, we have P, which is x, this one again, and also x for P sub L, plus the quantity of y for P minus negative c. Alright, so this is negative c. Okay, let me do it right. This is negative c. Okay, so let's continue. So if we will try to simplify that, let's move it here, this part. So we have x minus 0 is just x squared plus y minus c quantity squared plus the square root of this one becomes 0. X minus x becomes 0 squared, so we won't write that anymore. And then we have y, this negative minus negative c, that becomes plus c quantity squared. Okay, this is actually equal to, okay, equal. And then we square both sides of the equation. So we remove now the radical sign to both sides. So we have x squared plus y minus c quantity squared equal to y plus c quantity squared. And then we write together, we place together the groups with the same variable. So we move this, we transpose this to the other side of the equation. So we have x squared remaining on the left equal to y plus c squared minus y minus c quantity squared. And then we try to simplify it. So we have x squared equal to, this one is y squared plus 2cy plus c squared minus the other binomial is y squared minus 2cy plus c squared. And so we have now y squared plus 2cy plus c squared minus y squared plus 2cy minus c squared. Okay, and then this c squared and minus c squared can be deleted. That's equal to 0. And so is y squared and negative y squared. So what will remain on the right are these two 2cy's. So we can add them both, this one and this becomes 4cy. And this is the equation of our parabola. Alright, x squared is equal to 4cy. Now what happens if our parabola is opening downwards? As you can see in our figure, the parabola opens upward. Okay, and the formula is x squared equal to 4cy. And this parabola has the vertex v at 0, 0. Okay, so what do you think happens when the parabola opens downward? We still have the same equation, only that our c becomes negative because c is actually a directed distance from the focus to the vertex. So it's from the focus to the vertex. Alright, so if c is positive, it means the graph is opening upward. C becomes positive, so that would be x squared equal to 4cy, that one. So if it goes downward, this would become 4, and your c is negative because your distance now is going down. So since it's a directed distance, so that becomes negative. And so you have x squared equal to negative 4cy. Okay, so this board is quite crowded now. So we use this formula, we use this equation if c is positive, and we use this one if c is negative. Means that this one, the graph opens upward, and this, the graph opens downward. All right, let me show you an example. All right, let's continue. So if the graph, again, if the vertex is at the origin 0, 0, and the graph opening is upward, it means that your c is positive. The equation would be x squared equal to 4cy. But if the vertex is again at 0, 0, but the opening is downward, so its c is negative, the directed distance, then we have x squared equal to negative 4cy. So for instance, if the graph opens that way, okay, this is your focus and this is your directrix, automatically your equation is x squared equal to 4cy, y and our x. But if the graph opens downward, all right, this is our x, our directrix. Our directrix now will be on top. Okay, this is our L. This one is our L for the first graph, and this is our focus. Therefore, the graph goes that way. All right, so the equation of this graph, of this parabola, is x squared equal to negative 4cy. So I hope you have seen the difference here. Again, c is the directed distance from the vertex to the focus. Okay, vertex to the focus. So here, from the vertex to the focus, it's going down. It's c, so that c there becomes negative. But here, it's going up. From the vertex to the focus, it's going up. Okay? Now, what happens if when your graph opens to the side? Opens to the right or opens to the left? Let me show you. Okay, so this is the illustration and how the equation would be like when your parabola opens to the side. Okay, so for instance, the focus is here. This is F. This time, the coordinates of F, if this is 0, 0, then if that's C, then our X here becomes C, the X coordinate. So that would be C0. And if this is also C, this one becomes negative C to the left. And this would be our L. And L would have an equation that's X equal to negative C. Okay? And so, the parabola would look like this. Opening to the right. So your question now is there really a parabola that opens to the right or to the left? Well, the answer is yes. In analytic geometry, we can have those. Okay, so this is now our parabola. And the problem is, what would be the equation of our parabola? We determine now one point. Let this point be P. And P has coordinates x, y. The same thing that we did when we had the illustration on the formula or the equation of the parabola when it is vertical, opening up or down. So if we extend our directrix going that way, okay, so we can say that if P is on the parabola, the distance from P to F is equal to the distance from P to L. Okay, this is P to line L. So this point here would be our P sub L, and P sub L would have the coordinates for X is negative C, and 0, Y for Y. Whatever your Y is, your X is negative C. So this would be our P to P sub L. Okay, and from that, based on the definition of a parabola, the distance from P to F is equal to the distance from P to P sub L. Okay, so again, let's try to determine the coordinates first of this point, so it would be easier for us to work on this when we try to use the distance formula. So for P, we have xy. For F, we have the coordinates C0. And for P sub L, the coordinates are negative C and Y. And so using the distance formula, we can have now squared plus this one squared. We put now the coordinates for X and Y. So for P, we have X. For F, we have C. X minus C. And for Y, we have Y minus 0. For the second one, we have P, this one, the X again, X minus negative C. Okay? And for Y, we have Y minus Y. So when we simplify this, we square both sides of the equation, so we can remove the radical sign there. And so we have X minus C quantity squared plus Y minus 0 is just Y squared. This one becomes X plus C quantity squared. Again, this is negative C. Okay, that's negative C. And Y minus Y is just 0. And then we write the groups with the same variables to the right. So what will remain here at the left is just Y squared. And we have X minus C, X plus C quantity squared minus X minus C. And we expand that. Okay, so this one becomes X squared plus 2CX plus C squared minus this group here. This becomes X squared minus 2CX plus C squared. And we simplify that further. So we have X squared plus 2CX plus C squared minus X squared plus 2CX minus C squared. So this term and this can be removed. They are equal to 0. This and this also, we remove it. And we finally have just Y squared equal to 4. 2CX plus 2CX is Y squared equal to 4. Let me write that clearly. We have Y squared equal to 4CX. So what can you say now? What's the difference between the formula for a graph, the equation of a parabola that's opening to the right, and the equation of a parabola that opens upward? You see, if we will try to flip the graph and make that parabola open to the left, since C is a directed distance from the vertex to the focus, then the formula would be Y squared equal to 4 negative CX, which is equal to Y squared equal to negative 4CX. So this is the formula, the equation when the parabola opens to the right, and this is the equation when the parabola opens to the left. Okay, and this only happens when the vertex of the parabola is at the origin 0, 0. All right. So the question now is, what happens to the equation when the parabola has its vertex at HK? I mean, generally, if the vertex is at HK, what's the equation of the parabola? What if it is not on the origin? Let me illustrate it to you. Okay, so let's try to recall first before we go to a parabola with the vertex at HK. Let's try to recall what we have discussed already, that for a parabola whose vertex is at the origin, that's coordinates 0, 0, the parabola that opens upward has an equation equal to x squared equal to 4cy. But when it opens downward, the equation would be x squared equal to negative 4cy. When it opens to the right, okay, that becomes y squared equal to 4cx. And when it opens to the left, that becomes y squared equal to negative 4cx. Now, what happens when the parabola has its vertex at HK? Alright, so the same thing with the equation of the circle. If the center of the circle is at the origin, then the equation would be x squared plus y squared equal to r squared. But when the center is at HK, that would become x minus h quantity squared plus y minus k quantity squared equal to r squared. So the same thing with here. When your vertex is at HK, the equation of the parabola that opens upward would be x minus h quantity squared equal to 4c times y minus k. Okay? When it opens downward, this would become x minus h quantity squared, but this one is negative 4c y minus k. And when it opens to the right, this would be y minus k quantity squared equal to 4c times x minus h. And when it opens to the left, this would be y minus k quantity squared equal to negative 4c x minus h. And this is the standard form of the equation of a parabola. Again, the standard form of the equation of the parabola is x minus h quantity squared equal to 4c times y minus k when the graph opens upward. This one becomes negative when the graph opens downward. When the graph opens to the right, that would be y minus k quantity squared equal to 4c times x minus h. When it opens to the left, that would become y minus k quantity squared equal to negative 4c times x minus h. And this is the theorem for that. Okay, let me write it here. Theorem, equation of a parabola in standard form. So if we have a vertical parabola, either opening upwards or downwards, it would be x minus h quantity squared equal to 4c times y minus k. Again, the c here, do not forget the c is a directed distance. So this becomes negative when your c, when the distance from the vertex to the to the focus is, the vertex to the focus that's going down, then the c would become negative. And our horizontal parabola would have the equation y minus k quantity squared equal to 4c times x minus h. Again, the c here is the directed distance from the vertex to the focus, and if the graph opens to the left, then c would become negative. And these are the equations of our parabola in standard form. For the vertical parabola, it would be this, and for the horizontal parabola, opening to the right or to the left, this would be the equation in standard form.